Hello students. Okay, through this video let us try to summarize the first chapter, that is chemical reactions and equations. So in this chapter what and all we have learned you can recall through this video. That is, the first thing is we have learned some evidences for chemical reactions, types of chemical reactions, balancing chemical reactions. These are some things we have learned in this chapter mainly. Now, what is a chemical reaction? When two or more substances combine to become a new substance, right? At that time we call it as that whole reaction we can call it as chemical reaction. Usually chemical reactions are irreversible. Usually some chemical reactions can be reversible. So a lot of elements, to attain stability, they undergo these chemical reactions. So whenever they undergo chemical reactions, the old bonds will get broken up and the new bond formations takes place. So how do we get to know whether the reaction is happening or not? So for that we need to understand the evidences for chemical reactions. There are some processes will happen when reaction is happening, and these processes will tell you whether the reaction is happening or not. Very first thing, change in state. The physical state will change when chemical reactions are happening. Not all the changes where physical state involved, you can't consider them as no. Now for example, ice getting converted into water, that physical state change, that you can't consider as chemical change. But here you can see the reactant and product you have to compare, because I am taking hydrogen and oxygen. So hydrogen is in gas form, oxygen is in gas form. So both the physical state is gaseous form. But after they combine, I'm getting water, which is obviously a liquid. So you can see reactant and product comparison, change in physical state is happening. So change in color. So maybe raw mango, if you take it, is green in color. So a ripened mango, yellowish, right? So that yellowish color formation, you can say that chemical reaction is happening in it. Right. So the then third example, evolution of gases. It is also one of the evidence for you to understand whether the reaction is happening or not. You can see into zinc granules, when you add small amount of HCl, hydrogen gas will evolve. So wherever gases are getting evolved, you can consider there that chemical reaction is happening. At last, change in temperature. So some reactions, temperature may increase, and some reactions, during reaction temperature may decrease. So change in temperature also can be considered as one of the evidence for chemical reaction. Even you can add formation of precipitate is also one of the evidence for the chemical reactions. Fine. So let's go to the next topic then. Whatever chemical reactions are happening, earlier people used to write in sentences. That is quite difficult. Then later they started writing only the names of that chemicals. Like example, you can see on the board, sorry, on the screen, I have written magnesium and oxygen, and product side you can see magnesium oxide. So earlier they used to write the word completely, magnesium plus oxygen gives magnesium oxide. That we call it as word equation. Now even that also we have reduced, we use only symbols and formulas now. If you are representing a chemical reaction with the help of symbols and formulas, then we call it as a chemical equation. And usually some equations are not balanced. You can see the first one, whatever I have given, magnesium and oxygen. Left side, that is reactant side, oxygen has 2 atoms, and in product side oxygen has only 1 atom. I have just represented chemical equation, but I have not balanced it. But balancing chemical equation is very, very important. We all know why do we need to balance these equations: to satisfy the law of conservation of mass. So what do this law states? This law states that you can't create mass and you can't destroy the mass. That means mass can neither be created, mass can neither be destroyed throughout the chemical reaction. Now, if I'm taking maybe 1 kg of magnesium, I can see in product also 1 kg of magnesium. But in reactant side, I'm taking 2 kg of oxygen, but in product side, I'm getting only 1 kg. That means 1 kg has vanished. That can't happen practically. So you have to always write a balanced chemical equation. So how do we do this balancing process? Now, to balance the chemical equations, first we need to put the box to the given skeletal reaction. whatever equation they have given. For that, just put a box. Now for Mg also you can put box, O2 you can put box, MgO you can put box. That box tells you that you should not change anything in whatever they have given, right? So next to Mg, next to O2, whatever we call it as coefficient, there you can put some numbers like 1, 2, 3, 4. So maybe minimum you have to start with 2 to balance the product side. Very first thing what we have to do, we need to find out how many elements are present in the whole equation on both left and right side. Then you need to find out how many atoms are there in each element. Then the third thing, you need to start balancing the element which contains more number of atoms, right? So if we follow these three things, it is very easy for us to balance the chemical equations. I hope a lot of examples we have done in the class, so you can refer your classwork for those examples. So let's go to the next topic, that is types of chemical reactions. We have 5 important types of chemical reactions. In that, the first one is combination reaction. The name itself is telling that combine. Two simple substances will combine to give a complex substance. That's what the chemical combination reaction will tell you. You can see an example. I have taken hydrogen and oxygen. I'm getting water. Hydrogen, oxygen, you have to take as simple substances. Water you need to consider as complex substance. Second example also same. I have taken magnesium and nitrogen. I'm getting magnesium nitrate as a product. So this is combination reaction. Let's move to the second type of chemical reaction, that is decomposition reaction. The name itself will tell decompose, break down. So here in this case, a single huge product, okay, or complex reactant will break down into 2 or more simple products. So in this case, you need to supply the energy. You need to supply the energy for the reaction to happen. You can supply the energy either in the form of heat or in the form of light or in the form of electricity. Now if you are supplying energy in the form of heat, then we call it as thermal decomposition. You can see an example I have given on the slide. I am heating calcium carbonate. When we heat calcium carbonate, we get calcium oxide and carbon dioxide. You can see in the tube the carbon dioxide collection is happening, right? So thermal decomposition, heat is given as energy. Second case, that is photolytic decomposition. Photolytic, sunlight is given as energy. So if I take silver chloride, so silver chloride actually solution will be stored in colored bottles. If you take a transparent bottle, when light falls on it, silver and chlorine will get separate, right? So here sunlight is given as light energy is giving in the form, so we are giving light energy in the form of we are providing light as energy for the decomposition reaction. Then the third one is electrolytic decomposition. So here we are providing electricity as energy for decomposition reaction to happen. So you can see water, we are trying to break down the water into hydrogen and oxygen. You can see hydrogen and oxygen collection there. But one thing we need to understand here, oxygen quantity, how much is there? No, hydrogen quantity will be always double of it, because you know the formula of water, H2O. That means every one water molecule you break down, you will get 2 hydrogen and 1 oxygen. So obviously always hydrogen quantity will be more than oxygen. Fine. So that's about decomposition reaction. Let's go to the third one, that is displacement reaction. You can see A plus BC gives AC plus B. As general reaction I have written there. A and B you have to consider as metals. And usually in this reaction, highly reactive metal displaces the less reactive metal. Now let's see the example there. Zinc, you are trying to react with HCl. Now zinc and hydrogen, if I compare those two things, you can see activity series I have given there. Zinc is most reactive because hydrogen is below zinc. That means zinc can easily displace hydrogen from its salt solution. So Zn plus HCl, ZnCl2 plus H2. Zinc is taking the place of hydrogen along with the chlorine. So this is a displacement reaction. Then double displacement. In this reaction, both the reactants, they exchange their radicals, right? You can see there AB plus CD I have taken, but A is combining with D and C is combining with B, exchange of radicals takes place. So these kind of reactions, we call them as double displacement reactions. You can observe the examples below. Magnesium chloride and potassium hydroxide, you can see just they are exchanging their positive radicals. Then the last type of chemical reaction is redox reaction. Any reaction in which oxidation and reduction both are happening together, such kind of reaction we call them as redox reactions. Let us try to understand the example. I want you to compare ferrous oxide, that is Fe2O3, and iron. If I compare these two things, one is from reactant side, one is from product side. So the reactant side, whatever ferrous oxide is there, if you see on product side, it is without oxygen. So anything which is losing oxygen, we call it as reduction. But in the second case, that is carbon monoxide is becoming carbon dioxide. That means it is gaining oxygen. So gaining oxygen is oxidation, losing oxygen is reduction. And both are happening in the same reaction. So we call that reaction as a redox reaction. So the second example also almost similar. You can just go through the second example. And with respect to electrons, if any substance is losing electron, then we call it as oxidation. If somebody is gaining electron, then we call it as reduction. So gaining and losing wherever will happen, that reaction also you can consider as redox reaction. So these two, that is corrosion and rancidity, are the best examples of natural redox reactions. So when metals exposed to moisture and atmospheric air, they will corrode, they lose their strength and they lose their upper layer, right? So that is what we call it as corrosion. To protect the metals from this corrosion, we need to apply oil, grease, painting, galvanization, anodization, all these things basically we do. Even alloying also we will do for protecting metals from corrosion. And what is rancidity? When oils and fats exposed to atmospheric air, they will get spoiled and they give foul smell and bad taste. So that process we call it as rancidity. So what do we do to protect the food from rancidity? You might have seen chips packets, all packed food items. It will be flushed with nitrogen so that the food should not come in contact with oxygen, right? And even you can store the food in refrigerator, and even you can add preservatives, right? At higher and lower temperature also, basically rancidity won't happen. So this is about best example for natural redox reactions. So hope children, with this video we are clear about topics which we have learned in first chapter. Remember, evidence of chemical reactions we have learned. We have learned about types of chemical reactions and how to balance the chemical reactions. That's all with this video, children. Hope this will give clarity about the first chapter. Thank you, children.